So today we have an easy geometrical problem. The previous two geometrical problems were really difficult, not that difficult, but yes, they were difficult. Now this one is a little bit easy. First of all, let us understand what the question is. So basically it says that we have a semicircle, and inside this semicircle we have this kind of setup of chords and line segment, and from this we have to find what can be the value of x if the chord, not the chord, the line segment above and the line segment below have the length 3 and 4 respectively. Okay, so now according to me this one is an easy problem. You can solve it very nicely, just a little bit of thinking is required, or else let us see in this video how is my solution to this question. So the first thing that we can understand is that as we have a semicircle, we should utilize some of it. So the first thing that comes to my mind is to use this particular theorem, that angle inside a semicircle is always 90 degree, or else you can say that the angle subtended by the diameter of the semicircle on its circumference is always 90 degree. So it basically means that if you have the diameter and the semicircle, then the diameter will always subtend an angle of 90 degree on the circumference of this semicircle. Okay, so now this thing can be utilized in this particular diagram three times. As you can see, we have only two kinds of setup. Let me just erase this diagram and make it clear, just a few seconds. Okay, so this angle is always 90 degree. Now as I told you, in this diagram we are going to use this theorem three times. Now let us see how. The first thing is that this angle is clearly 90 degree, and so is this particular angle. Okay, now look carefully. What if I join a line from here to this particular point x, and again from this x to this bottom corner? We again have this pink triangle that is from the endpoints of the diameter, and it is also subtending an angle at the circumference, and this particular angle would again be 90 degree. Okay, now let this perpendicular drop. Yes, this angle is 90 degree. It's sorry I didn't mention, but yes, this angle is 90 degree. Now what I will do is let the length from AP equals to small variable a, and the length BP is equals to small variable b. So this length I have taken as a and this as b, and not to mention, sorry, I forgot to mention this also, that this is not the center. If some of might you have confused it as the center. Okay, now we are good to go. The first thing is that as you can see we have this right angle triangle on this particular side. Let me just name this top point as M, so now it would be clear. So in the triangle APM, you can see by Pythagoras theorem we have that AM square, the hypotenuse square, is MP square plus AP square. Hence what we will have is AM square is equals to, what is the value of MP? It is going to be 4 plus x the whole square plus AP square, means it is going to be a square. Hence the value of AM square is finally going to be 4 plus x the whole square, basically the same thing I wrote, sorry. So AM square is going to be 4 plus x the whole square plus a square. Similarly on the other side we have this right angle triangle. If I will name, you can easily understand. The triangle is triangle PMB. In that triangle, if I apply the Pythagoras theorem, I have that MB square is equals to MP square plus PB square. So the hypotenuse MB doesn't have a value, so MB square. The height is again 4 plus x the whole square, but this time the base is B square. So finally we have that MB square is equals to 4 plus x the whole square plus B square. Nice. Okay, now look carefully on the right angle triangle that I will mention now. So now take the triangle AMB. Now I am talking about this biggest right angle triangle. So now this time the length AM is the height and MB is the base, means they are the sides AM and MB. And now the role of the hypotenuse is placed by AB. So AM square plus MB square is definitely going to be AB square. Let us substitute the value. AM square has a value 4 plus x the whole square plus a square, and MB square has a value 4 plus x the whole square plus b square, means it will become twice n plus b square. Now what can you say about AB square? So look carefully. AB has a value a plus b because the lengths are basically a from here to here and b from here to here. Hence the overall value becomes a plus b. Nice. So AB square will be replaced as a plus b the whole square. So finally 2 times 4 plus x the whole square plus a square plus b square is equals to a square plus 2ab plus b square. A square b square got cancelled out, And finally we will have this equals to 2ab, so 2 and 2 can also be cancelled out. Hence 4 plus x the whole square is equals to ab. So nice, we have got something that the variable that we have put from our side in this question were a and b, and we have got its value in terms of somewhat x. Let this be an important equation 1. Now, while solving this particular question, I means my side I have just done a lot of rough work that what can be the values that I can get from this question, and I was already having a value for AB when I was solving. I was already having a nice value of AB, and this is what I have got. Let me just remove this pink line because they are not needed. Wait, yes, this pink line are not needed now. Oh, sorry. Yes. Now look carefully in this particular triangle. Let this top point be, previously it was n, now let it be ABC. Okay, so look carefully in the triangle APC. So in this particular triangle ABC, if I take this angle as theta, so this angle is 90, that angle is theta, so we'll have an alternate or the complement pair. So this one is theta, so the complement pair, this one would definitely become something 90 minus theta, but instead of writing 90 minus theta, let it be equals to alpha. Okay, now look carefully again, we have this right angle triangle over here. So if that top angle is alpha, this angle is 90, hence the complement pair, that is theta, would come out to be over here. And as these lines are straight lines, by vertically opposite angles are equal, that angle theta would come out to be over here. Now just the theorem that I mentioned, vertically opposite, let me just vertically opposite angles are equal. So what is this? It says that if there are two lines that are definitely a straight line, then and then only this angle is theta, then this angle is also theta. Similarly, if this angle is alpha, this angle is alpha. And if the lines are not straight, then this theorem doesn't work over here. The lines should be strictly straight. Therefore, I starting mentioned that these lines are straight lines and they are line segments and the chords. Okay. So yes, theta and alpha are the complement pair. What is the meaning of the word complement? Let us understand that also. So the word complement angles means that two angles that have their addition equals to 90 degree. Okay, so theta and alpha are the complement pair. So if this angle is theta and this angle is 90, so we can take that angle as alpha. Now in this particular triangle we again have that pattern, so if that is alpha, this becomes theta, then by vertically I have this equals to theta. Now look carefully, all of this setup is done. Now from this triangle APC, in the triangle APC, we have this angle theta, hence we can have the value of tan theta, and it is going to be what? The complete height is 3 plus x plus 4 and the base length is a. So hence we will have 7 plus x upon a. Similarly, we can have the value of tan theta from this triangle. This point was M previously. So from the triangle PMB. So from this triangle PMB, we can again have the value of tan theta. Tan theta is basically opposite upon the base. So the opposite is b and the base is 4. So from this triangle, the value of tan theta what I have got is b upon 4. Now look carefully, both of these values are of tan theta. Therefore, b upon 4 is same as 7 plus x upon a. Doing cross multiplication, we will get ab equals to 4 times 7 plus x. Hence the value of ab would be 28 plus 4x. Now look, as I told you, we should get the value of ab in terms of x, and here it is the value number 2. So comparing these two values, we can just move on to the final part, and hence from 1 and 2. One thing I forgot to mention, that I got to this AB equals to 4 times 7 plus x using trigonometry. You can also do this by similarity. There's no issue in that. So from 1 and 2, what I can say is that 4 plus x the whole square is going to be 28 plus 4x. Yes, the values are same. Now opening the bracket over here using the identity of a plus b the whole square, it would be 16 plus 8x plus x square is going to be 28 plus 4x. Doing basic calculations, x square plus 4x plus 16 minus 28 means negative 12 is equals to 0. Factoring out this quadratic, we will have x plus 6 multiplied by x minus 2 equals to 0, and hence we will have the value of x either negative 6 or positive 2, and clearly x is a side length in a particular geometrical diagram, hence it cannot be negative. So finally x equals to 2, that is the length of that particular line segment in the yellow that you can see in the particular diagram. And talking about how we solve this quadratic, it's very simple. X square 12 factor outside 6 into 2, and 6 and 2 gives us 4 also. So x square plus 6x minus 2x minus 12 equals to 0. I take out x common, so x plus 6, negative 2 common, so x plus 6, and finally x plus 6 taken common out, so x plus 6, x minus 2 equals to 0. Some might of you must not need this particular step, but few of them still need, so it's good for them. So this was a easy geometrical problem, not too difficult and not too lengthy also. But let's see, I have planned few difficult geometrical problems in the upcoming videos. This one is easy, and do let me know if I should also post some of the floor functions integration. I have some of that questions also ready. I will do post, but I just want to know your opinion, that you need that or do you need these geometrical problems. Okay, so this was my way to solve this particular geometrical problem. If you have any other method other than this, you can do comment below. And if it's a photo or a video, you can email me at the email address that is in the description. What's today's date? It's 26th of April 25. Okay. So thanks for watching this video, and bye bye.